Hello. Last class we discussed about QPSK signal, and we looked at the constellations and how exactly we can generate sine and cosine and how they differ. And we discussed that there is 90-degree angle difference between each constellation with the neighbor one. Now we are going to look how we can expand this type of modulation and how exactly this system is generating these waves. Now later on you're going to see that this type of constellation from theory point of view is called offset QPSK, and there is a small difference between the QPSK and OQPSK or offset QPSK. Here I'm showing the block diagram, and it is taken from this resource. If you want to read more and you're interested, you can look at that link. Now you can see that here the data in binary form is given to this system, and then I have the LO here. LO stands for local oscillator, and the oscillator is generating the carrier signal, which will be a sinusoid, and then the sinusoid is directly given to this block here, which is going to generate my I, and then with the phase shifter on the way, the signal is generated for Q. If you notice, I have the word PSK here and PSK here, PSK for I and PSK for Q. The reason is because we have that phase shift key happening here. So it makes sense that we are saying that we are using a combination of phase shift key to generate QPSK signal. And the phase shifter is the block that is generating that angle difference. And as you remember, last week we discussed that with adding or subtracting 90-degree angle, we can transfer, we can convert a sinusoid, a sine, to a cosine. That's why we have this shifter here to have the I and Q generated. And in this case, in this example that I have here, I'm pairing the bits and I'm using constellation to transmit one of these combinations. And you can see that I have 0, 0, 1, 0, 0, 1, and 1, 1. So depends on what constellation I assign to send. Later on, I am going to explain how exactly we decide which constellation for which bit combination. But I have 4 options to send. So in this case, you can see that the carrier signal, the wave is the same, pretty much the same. When I'm transmitting the 0, 0, that means that I'm not changing the carrier signal that much. But when I have the combination of 1, 0 bit for transmitting this wave, I'm changing the carrier signal and I'm pretty much flipping it. You can see the flipping effect here, because if I was sending the usual carrier signal, I would continue and going up and come down and up and down. Now you can see that I have this flip. Now if I want to send the 0, 1 combination, I have even more phase shifted happening here, and also for the 1, 1 combination. Now in next slide, I'm going to show exactly why I say that there is offset happening for OQPSK and what is the difference between OQPSK and QPSK. Now this table is one example how I can have different combination of bits and how I can transmit them using QPSK and OQPSK. From practical point of view, when I have the 90-degree angle, I'm calling it OQPSK. And you can see that my first bit can be transferred by using this constellation here. So here, this one here would be associated for 0, 0, and the reason is because I don't have any angle. The angle is 0 degree. Then when I have that 90-degree angle, then my constellation will be associated with this one here, and then I can transfer the 0, 1 bit with that constellation. And if I have another 90-degree angle added, or altogether I have 180-degree, then I can associate this constellation at this point with the bit that I have for 1, 0. And then furthermore, another 90-degree angle, then I can have this one here. For this constellation here, I have two ways of looking at the angle. One is the positive one, which will be calculated from this point coming all the way here. And another way of looking at is to have negative angle, or coming from the opposite side. Sorry, I moved that arrow. So that will be the two types of looking at this constellation at this one. Now if I have that offset in place and I'm looking at all QPSK constellations, I am going to transfer the first combination with one of these constellations here. For this example, if I say that my negative angle or my minus 45-degree angle is associated with this one, so I'm talking about this example in this table. If I want to associate the negative phase for my first combination, I'm going to send 0, 0 with this constellation here. And if I want to associate the positive one, so I'm going to send the 1, 1 here. Now, the other two at this point will be assigned for the 1, 0 and 0, 1. So here, this one here will be the angle calculated from this point all the way here. And then the other one will be for calculating the angle from this point to here. So this will be the difference between the QPSK and QPSK. Now, if I want to expand this type of modulation, if I want to keep the absolute or amplitude of the signal the same, and I want to change the angle only, so I'm going to have a circle and moving along the circle. So it's pretty much like holding a pen attached to a piece of a string and moving it along a big circle. So you can see that I have more combinations. In this case, I'm scaling it 4 times. So I'm looking at a 16 QPSK signal. Now, I have more options and I can have more combination of bits. And I'm using this system a lot more efficiently. This scheme is very popular and it has many applications. Now I'm going to compare this with QAM. So in QAM, I'm not only changing the angle a little bit, but also I am changing the amplitude. That's the name come from. So in this case, the amplitude of this point here and this point here are the same, but I'm changing the angle. And if you notice, this point and this point are on the same line. So I'm just changing the amplitude and I'm keeping the angle the same. So I can have positive values and I can have other types, combination of negative and positive. And I can have 16 constellations. So this would be the difference between the QPSK and QAM. The next thing will be the discussion that I'm going to ask you to tell me what protocols in IoT are using these two types of modulations. Thank you.